Alright guys, so we talked a little bit about this today during our activity, but I want to go over this again so you have a better understanding of dividing decimals using powers of 10. In our last notes we talked about negative powers of 10 to the negative first, meaning 1/10, and 10 to the power of negative 2, which is 1/100th. So I'll just flip over my notes so you can see this. And we're going to be using this today to talk about dividing decimals. I had you somehow put this into your notebook so you didn't have to write it all out, because we will be going over this. So I want you to go ahead and take a look at the division problems to see if you can find the pattern, and use the patterns to describe the dividends, divisors, and quotients in each set. So if we look at the first problem, we have a positive whole number divided by a 1/10, and our quotient is 40. We have the same dividend, and that is 36, but we have a different divisor. We have a 9/100ths, and that gives us 400. Then we divide the same dividend by 1,000th, 9,000th, and we get 4,000. And so what do you think we'll get if we divide 36 by a 10,000th? Hopefully you see a pattern: 40, 400, 4,000, 40,000. So we're going to use this pattern to describe the dividends, the divisors, and the quotient. Okay. The dividend, the one that's being divided, stays a whole number. It stays the same, right? But as the divisor, this is the divisor, as the divisors get smaller, so here we have 9/10ths, it gets smaller to 9/100ths, it gets smaller to 9,000ths, it gets smaller to 10,000ths. We're getting further and further away from a whole. As the divisors get smaller, the quotients, what happens to the quotients? The divisor gets smaller, it gets further away from 1, the quotients are getting larger. Okay, so there's a pattern that we see. Let's go ahead and look at the next set of problems. Now instead of looking at, here I'm going to label this as dividend. Now our dividends are changing, but our divisors stay the same. So right here I'm going to write divisors stay the same. What is happening here with our dividends? Our dividend starts at 3 6/10, then it goes to 36 hundredths, then it goes to 36 thousandths, then it goes to 36 ten-thousandths. Our quotient is 4/10, then it goes to 4/100, then it goes to 4/1000. So what will this one be? 4/10,000. So what is happening in our pattern? As the dividend, this number, as the dividend gets smaller or further away from 1, what happens to our quotient? The quotient also gets smaller. And you will notice, kind of like how I said when we multiply a decimal, or we multiply a whole by a tenth, our answer is going to have a tenth in it. Okay? Here I'm dividing a number with a tenth by a whole, and I get a tenth. Here I divide 100th by a whole, I get 100th. Here I divide a 1,000th with a whole, I get 1,000th. Here I divide a 10,000th by a whole, I get a 10,000th. All right. Here's our next one, and it's completely filled out for us. So, let's see. Here are our dividends. Here is our divisor. And let's look at this pattern. I have a tenth divided by a tenth, well, a whole and a tenth, divided by just a tenth, and I get a whole. So it's almost like this tenth and this tenth cancel each other out to give me a whole. I have 100th divided by 100th, I get a whole. I have 1,000th divided by 1,000th, and I get a whole. What goes here? A 10,000th, because this is 36 10,000ths. Tenths, hundreds, thousandths, 10,000ths. Tenths, hundreds, thousandths, 10,000ths. And I get a whole number. So here we're going to say the quotient is a whole number when a decimal is divided by the same decimal place. And I don't know if that makes a lot of sense when we read it, but it makes sense when we look at it, right? A tenth divided by a tenth. So here, I'll write that. Hundredth divided by 100th, and so on and so forth, if we look at the pattern. Okay, so now that we've talked about that, I want to talk about why that works. And we're going back to our powers of 10. And using the powers of 10 will help us to divide decimals in a much easier fashion. We talk often about moving the decimal place over, and the main idea here is, why can we move the decimal place over? Okay, so I'm going to flip my page over because I'm out of room. And here is the main idea of what we're doing. What does it mean when we move the decimal place, and why does it work? And this also goes with multiplication, which we've talked about, okay? When we have had a problem like 0.9 times 0.3, we know that our answer is going to have 2 decimal places in it. So all I have to do is multiply 9 times 3, which is 27. And then I know that my answer, I have a decimal place here and a decimal place here. I'm hoping my screen will, there we go. Decimal place here, so it goes in 1, and a decimal place here, so it goes in 1. So my answer is going to go in 2. 1, 2. We've learned that. Okay, that kind of quick, easy way. I'm multiplying a tenth by a tenth, so my answer will be 100th. That's why it works. That's why we move it. We know we have a tenth times a tenth equals 100th. This says 9 tenths times 3 tenths. And when we multiply straight across, it gives us 27 hundredths, which is this. This is what it looks like in fraction form. It's very similar when we divide, and we have to understand why we do what we do. All right, so using these same numbers, I'm going to show you an example. I have 9 tenths divided by 3 tenths. And what we saw over on this other side is that if I'm dividing a tenth by a tenth, I get a whole. And we're going to see if that really works. So what I'm going to do is I am going to multiply both of these by the power of 10, just 1 10. And you will see that when I multiply this power of 10, well, let's do it. 0 times 9 is 0. 0 times 0 is 0. I have a placeholder. 1 times 9 is 9. 1 times 0 is 0. Okay. I have 1 decimal place here, so I'll go 1 here, and my number is 9.0 or 9. Over here, it's going to be the same thing. 0, 0, 0. 1 times 3 is 3. 1 times 0 is 0. I have 1 decimal. I have 3.0, which is the same as 3. And I move my division sign. 9 divided by 3 is 3. Because I'm able to move this decimal place over, if I just said move this one once and move this one once, I'm moving them both over once because I'm multiplying them both by 10. And I can do that because 10 is the same number. Let me show you example B and we'll compare what we did. Our problem now is 98, a whole number, divided by 14 hundredths. To make the division easier on ourselves, I want to get rid of this decimal point, so I have a whole number. It's easier to divide whole numbers, it's true. It's easier to divide whole numbers. So I'm going to get rid of that decimal. That's what I'm going to say. I'm going to get rid of it by moving it 2 places over to make a whole number. Okay, what I do to this, I have to do to this. And if I move this decimal place over, what does that mean I'm actually doing? If I multiply this by 100, I get rid of my decimal place. So this will all be zeros. This will all be zeros. This will be 4. This will be 1. This will be 0. I go in 2 decimal places. My answer is 14.00, which is the same as a whole 14. Now that I've gotten rid of, I use rid of with quotation marks because there's still a decimal in this number. I've just moved it. 14 still has a decimal in it. I just moved it. Now I have 14 wholes instead of 14 hundredths. But because I multiplied this number by 100, I have to multiply this number by 100. And if you remember the rules of multiplying by powers of 10, which you should have learned in 5th grade, and 5th graders, we did it already this year, 98 times 100 just means 9800, or 9,800. So my new problem is 9,800 divided by 14. My problem looks different from here to here, but it's the same exact problem. And the answer will be the same exact thing. I promise you. And that's because we're using powers of 10. And it is much easier to divide 14 into 9,800 than it is to do 0.14 into 98. Because we think in whole numbers. So 14 goes into 98. How many times? I'm going to give you a minute to think. Try it out before I give you the answer. And if I go too fast, you can pause it and try and do it on your own. All right, so 14 goes into 98. Hopefully you found it 7 times. That's 98. I bring the 0 down. 14 goes into 0 times. I bring the next 0 down. 14 goes into that 0 times. So 98 divided by 0.14 or 14 hundredths is 700. How can I know that that is correct? Let me prove to you that this problem is the same as this problem. And I'm going to prove it to you by doing the opposite, which is multiplying. So I'm going to multiply 700 times 14 hundredths. And if I don't get a whole of 98, then I did something wrong. So 4 times 0 is 0. 4 times 0 is 0. 4 times 7 is 28. I have a placeholder. 1 times 0, 0. 1 times 0, 0. 1 times 7, 7. I move my decimal place in twice because I have a hundredth. I have a whole times a hundredth. My answer will have 2 zeros. It's a whole. It's the same as saying 98. It works. We can use powers of 10 to help make it easier to divide. Let me give you one more, maybe 2 more examples so you understand why we can do powers of 10. I am going to divide 2 decimals that are different places. I'm dividing a really small number because this number is in the 10,000s, tenths, hundreds, thousands, 10,000s, and I'm dividing that by a whole and a tenth. Okay, my decimals are definitely in different places. I'm going to try and get rid of one of these to make it easier on myself to divide. I'm going to turn this problem, this one that I'm dividing by, because this one goes in the house. This is what my problem looks like if I don't move the decimals. This is what my problem looks like. So in order to make this easier, there's a couple different ways I can approach this problem to quote unquote get rid of my decimals. I can multiply this by 10 and that will get rid of this one. That'll make it 13 into 0. It will move this one over 1. I will still have 0.338. And I still have to do 13 into 0.338. And I can do that. So I multiplied this by 10, I multiplied this by 10, I got this. I move the decimal over 1 because I multiplied by 10. If I do it this way, this decimal here goes straight up and I still keep dividing. 13 goes into 0, 0. 13 goes into 3, 0. 13 goes into 33. Okay, that's one way. I can multiply these both by 10. Or I could get rid of the decimals completely. Either way you do it, your answer will still be the same. So I'm going to try it. So let's finish this one first. Okay, 13 goes into 33 twice. That's 26. Thirteen goes into 28. How many times? So let's count by 13s. 13, 26, 39, 52, 65, 78. 6 times, evenly, thank goodness. So I get 0.026. If I were to leave this problem like this, I'd also get 0.26 because 1.3 doesn't go into this. Okay, let's try now multiplying it by to get this number as a whole number, I have to move my decimal place 1, 2, 3, 4 places. Which means I have to multiply it by 10,000 because it's in the 10,000ths place. So 0.0338 times 10,000 and 1.3 times 10,000 means that I move this 4 places. 1, 2, 3, 4. 3, 3, 8. You can do all the math if you want to prove it. 1.3 means I move this decimal place once and I get 13, and then I have 3 zeros left. Hold on, wait a minute. If you understood that, fast forward for the next 2 minutes. If you didn't understand what I just did, let me prove it to you. 0.0338 times 10,000. 0, this is going to be all zeros. 0 times 8, 0. 0 times 3, 0. 0 times 3, 0. 0 times 0, 0. 0 times 0, 0. Next one, placeholder. 0 times 8, 0. 0 times 3, 0. 0 times 3, 0. 0 times 0, 0. 0 times 0, 0. Okay, next one, 2 placeholders. 0 times 8, 0. 0 times 3, 0. 0 times 3, 0. 0 times 0, 0. 0 times 0, 0. 4 placeholders. 1, 2, 3. 0 times 8, 0. 0 times 3, 0. 0 times 3, 0. 0 times 0, 0. 0 times 0, 0. It's a lot of zeros. We've gotten nowhere so far, right? Okay? It's much easier to do it the quick way, knowing that the zeros and the decimals move, but this proves why it works. Okay? Now we're finally on. I have 4 placeholder zeros, okay, because I'm now going to multiply times the 1. Now I have 8. 1 times 3 is 3. 1 times 3 is 3. 1 times 0 is 0. 1 times 0 is 0. Okay? Oh my goodness. Look at all this work that I did. Now, 0, 0, 0, 0, 8, 3, 3, 0, 0. These zeros before aren't going to count unless I have a decimal somewhere in here. So, I'm going to move my decimal 4 places in. That's what this tells us. 10,000th, have a 10,000th here. 1, 2, 3, 4. 00338, the zeros before the decimal do not count. They don't mean anything. Alright, our number is 338, which I set up here. Okay, I did all this zero work to get the same thing. Moving it over. Okay, now, moving it over, moving our decimal is the easy way to say it. Okay, but we can move it over because this works. This multiplication works. And if we don't understand that this works, we can't do this. Okay, you have to really understand that you're multiplying by powers of 10. Same thing here. Okay, I'm going to do all the work for you. 1.3 times 10,000. It's actually easier to put the higher number first. And you don't have to set up decimals when you're multiplying. So 3 times 0, 0. 3 times 0, 0. 3 times 0, 0. 3 times 0, 0. 3 times 1, 3. Placeholder. Okay? Next one. 1 times 0, 0. 1 times 0, 0. 1 times 0, 0. 1 times 0, 0. 1 times 1, 1. Here I go. Here's my big long number, and I multiplied it by a 10th, So I'm going to have a tenth in my answer. This 0 after the decimal doesn't matter because we have a whole number here and nothing after the decimal. So my answer is 13,000, which I set up here. People, this is why it works. This is what we have to understand. Okay, so we're going to be doing some of this and proving our answers are right. And then once you know for a fact that this is why this works, the multiplication is why it works, then we can go ahead and willy-nilly move decimals all we want. We have to understand why it works. Okay, so now I have this, which is 338 divided by 1,000 or 13,000. This is going to be the same as 0.338 divided by 13. It's also going to be the same as 0.0338 divided by 1.3. All of these give us the same answer. I did it here. I got 0.026 or 26 thousandths. If I do it here, I'm going to prove that it's also 26 thousandths. We know what the answer is. Let's prove why it works. So 13,000 into 338. The first number always goes into the house. Top dog in the house. First number. 13,000 into 338. Guess what? I don't have enough. It's impossible. So my answer is going to be smaller than 1. So I put a 0 here, I put a decimal, I add a 0 here. This is how division works. With this decimal and this 0 added, I can keep going. 13,000 does not go into 3,380. It is still too small. So I put another 0 after the decimal and I add a 0 here. Now, 13,000 can go into 33,800. I have enough. And it's still going to go in here. I have 3 zeros. Here, I have 3 numbers. It's looking like 13 is going into 33. 3 digits here, 3 digits here. I'm covering them up. 13 into 33 is the same thing we did up here. Twice. 26. I get 7 left over. I bring down the 8. 13,000. Bring down my zeros. 13,000. Oh, I add a 0 here to the end because I keep just adding zeros until I can do it. 13,000 goes into 7,800 exactly 6 times. Our answer is still the same. We got 26 thousandths here. We got 26 thousandths here. How do we know our answer is correct? I'm going to multiply. Here's our original problem. We know that it equals 26 thousandths. I'm going to solve this by doing some backwards multiplication or some multiplication. I'm going to do 0.026 times 1.3 to prove our answer. 6 times 3 is 18. 3 times 2 is 6, plus 1 is 78. 3 times 0 is 0. 3 times 0 is 0. Okay. 1 times 6 is 6. 1 times 2 is 2. Here's my number, 00338. I have 1, 2, 3 decimal places here, 1 decimal place here. It's a thousandth times a tenth, which gives me 10 thousandths. 1, 2, 3, 4 decimal places in. This number equals this. That's why it all works. If you didn't understand all this mathematics that I just did, I recommend that you stop the video, go back, rewatch it, go through it again. We have to be able to prove that we can use powers of 10. And if we use powers of 10, they have to be the same power of 10 when we multiply. If I were to multiply this one, let's say by 10,000, like I did here, but only multiply this one by a tenth, my answer doesn't come out how I need it to come out because I'm not using the same power of 10. It will still come out with the 26 in it, but it won't have the decimal place in the right spot. Where the decimal place is the most important thing. Okay, so here's what I'm going to do. Oops, sorry. I would like for you to solve another problem. Actually, this one was the one I wanted you to do. Let me see if I have another one. Turning my paper over because I'm out of room again. If you still have room, keep going. I write really big. All right. Your problem is (127 divided by 4/10. I'm giving you the same decimal place, so it's not going to be as difficult as the one before. Use a power of 10 to rewrite your problem. Then solve it. That's the one that you're going to start with that we'll talk about tomorrow, and we'll talk about how to do it. Get used to doing it this way because we're going to do it for a little while this way. Okay, we have to really build that understanding of why we can do it and why it works, why we use the powers of 10, and how that relates to our decimal place. Very, very important stuff, because by the time you get to 8th grade, you're going to be doing so much of this, and you will have variables instead of numbers, and you will have variables that mean fractions of numbers, and decimals are fractions of numbers. So I really want to build your understanding of this right now. Okay? Rewrite this problem using a power of 10, like the example that I showed you, maybe example B or example A. If this was confusing to you, rewatch the video and ask lots of questions in class, because I will be meeting with you guys to make sure you understand it. All right, good luck. See you tomorrow.